Okay, number 11 is tricky, so here's a little bit of help to get you through that. The thing is you're trying to find out, if you graph it, you're supposed to get the rate when the yield is changing. It says the rate of change at each spot. So it's not asking about peaks or valleys or anything like that. It just wants the rate of change at various times. And that means first derivative, plug in these numbers. So if you take the first derivative of this, that's the tricky part on this one. So the hard part is you take the derivative of e and you rewrite the e function times the derivative of what's the exponent. So I rewrote it here, and I wrote it, by the way, emphasizing the fact that that's a divided by t. So right here, that's a really important thing to notice. It was kind of hard to see in the original that you're dividing by t. And then times the derivative of that exponent, which I have highlighted here. I'm going to go ahead and run through that. That exponent, if you want to derive that, you got to rewrite it as negative 0.0452t to the negative 1, and then use the power rule. So negative 1 times negative 0.0452 makes it positive t to the negative 2 because you subtract 1 from the power. That's your derivative that you plug back in up above. And then now all we do is plug in 5, 10, and 25 respectively into that derivative. And oops, I have a little error in there. I gotta go in there and fix that real fast. You don't want that. That's not squared. That's just over 5. But that's it. That's the function that you plug it into. Dun dun dun, and you get 14.2723, etc. So you just go for the 14.27ish, and then for the others, like I said, you just go in and you write in. You put in the 10, 25, etc. in for that t, replacing the 5 that you see here. Okay. Let me know if you have other questions, but that should do the trick.